Hello and welcome to the video on everything. Well, not everything, but just most of the things. So this video is about how we can combine what we know about the area of triangles with what we know about the area of, what were the other ones? Oh, parallelograms. And what we know about the area of trapezoids with everybody's favorite algebra thrown in there. So with these questions, you need to know all of the formulas and all of the ways that you can find different areas, so that way you can see, based on the information I know, what can I figure out, and how is that going to get me to my answer. So just a real quick recap, area of triangles is 1/2 base times height, or you could write that base times height over 2. Area of parallelograms is just base times height. And then area of trapezoids is 1/2 of the height times the sum of, base 1 plus base 2. And you might also write that as h times b1 plus b2 all over 2. Either of those are going to work for us. So in this first question, we know that trapezoid ABDE is made up of a square and a triangle. The area of the triangle is 44 square centimeters. And the length of CD is 11. So we need to find, I'm going to highlight this in purple, so that way I know I can do 2 separate calculations. We need to find those 2 things. Well, I know that squares, so, here we go. So let's get into this and see what we can find out, what we know. So in order for me to find the area of a square, I need to know the length times the width. But in order for me to find the length and the width, it seems like I'm going to have to use what I know about triangles to do some algebra and figure out some unknowns. So according to our formula for triangles, area of triangle is 1/2 base times height. And the base is always perpendicular to the height. That's key. So if we call this our base for the triangle, that must mean that this here is going to be the height. Now we're in luck because we know 2 out of the 3 pieces of information for that formula, which means we can find the third. So if our area is, let's use this 1/2 base times height. If we know our area is 44 centimeters squared and our base is 11, and we're trying to find the height, we have only one variable and we can solve for that. Now we have a couple different ways that we can solve this. If I multiply that 1/2 times the 11, I'm going to get a decimal, and that doesn't feel super great to me. So instead, what I'm going to do, there's a couple routes you can go, is I'm going to divide both sides by 11. Because if I divide this side by 11 and this side by 11, these two 11s are going to simplify down to a 1, which essentially cancels them out. And 44 divided by 11 is 4. Pretty easy. So I know 4 is equal to 1/2 of h. Now, 1/2 of h, if I want to undo that 1/2, I can multiply it by 2, because 1/2 will simplify it down to 1, and we'll be just left with h equals 8. So that must mean our height is equal to 8. But since ABCE is a square, we know that all the sides are 8. And so our area for a square, our square area, is length times width, or length squared. So our area is 8 times 8, which is 64. So that means the area of this square is 64 centimeters squared, and that area of that triangle is 44. So that means for our trapezoid, we can just take these 2 areas and add them together. Area of a trap will be 64 plus 44, which is 108 square centimeters. So we did a lot of calculations there, but I'm curious, I just want to double check and make sure. Do we get the same answer if we use our formula for the area of a trapezoid? So the area of our trapezoid, we need to know our heights and our 2 bases. So with this problem, if B to C is 8 and C to D is 11, that must mean that B to D is equal to 19. We also know that A to E is equal to 8. So in our formula, we know our height here, that's our height because it's perpendicular to those parallel sides, is 8. And we're multiplying it by the sum of the two bases. So that's the sum of 19 plus that 8 from up top. And then we need to divide that by 2. So A equals, let's do some simplifying. 4 times, what is 19 plus 8? And 27. And 4 times 20 is 80. 4 times 7 is 28. So the area is equal to 108 square centimeters. Yo, same deal that we did when we found the two parts. So this problem, you can see, takes a lot of knowledge here. You need to know something about geometry. Don't forget about that. Because you needed to know properties of squares, properties of trapezoids, that if our bases are parallel, then the height is the perpendicular thing to it. Plus, you needed to know the geometry of the area of triangles and trapezoids and the area of squares. Plus, you needed to know algebra, so that way you could solve for the unknown quantities, right there, to be able to get you that height. And then you needed to know what to do with that information. So this is a pretty hefty problem, but definitely doable. So another example of that, we have this situation here. Parallel or trapezoid PQTU, PQTU is made up of a parallelogram, PQRV, a triangle, and a square. So here we are with that geometry about squares where we know these are all going to be the same length there. The area of trapezoid, I'm going to do some highlighting here. PQSV is 99 square inches. So that means this area, PQSV, has an area of 99. And we need to find the area of the whole big trapezoid. So we need to find this whole green situation. Now, I remember from our last problem that if we knew the area and we know the bases, we could find the height. And that seems to be a useful way of thinking, because if we want to know the whole green area, the only piece that's missing is this square. And in order for us to find the square, we need to know the lengths of the sides. And the way that we can find the length of the side is if we find the height of this trapezoid. If we can find this h here, that will give us our length and our width that we could then calculate and then add. But there's something else that we need to know, and I'm not sure if this is going to be throwing you off in this geometry situation, but they tell us that this shape here is a parallelogram. And because it's a parallelogram, we know that opposite parallel sides are equal in length. If this one's a regular one, that means they're all equal, or an equilateral, or maybe even a rhombus. But it doesn't tell us a rhombus, so we can't assume that they're all the same. But we do know that in a parallelogram, that opposite sides are equal in length, or equilateral. So that means if P to V is 8, then Q to R must also be 8 inches. So if Q to R is 8 inches, that means Q to S is going to be 8 plus 6, or 14. So this is great news, because now for this purple trapezoid, we know the area is 99, we know base 1 is 14, and we know base 2 is 8, but we don't know the height. But we know everything we need to know. We can use algebra now. So 99 equals our height, which is h, times, let's see, the sum of our bases. So 8 plus 14 divided by 2. So let's do some simplifying. Let's solve. We just need to figure out what is our height, and then we can move from there. So 99 equals h times 8 plus 14 is 22, divided by 2. Now I could multiply both sides by 2, but then 99 is going to get way bigger, and then I'm going to have to do that. That's going to be too big. I want to keep my numbers small. So before I deal with that, I am going to simplify. So I can divide both of these by 2, and now I have 99 equals 11h. Inverse operations, h is equal to 9. So that means our height up here is 9, which tells us that our length is 9 and our width is 9. So the area of that square is 9 times 9, or 81 square inches. So trapezoid is 99, square is 81. We add them up, you get 180 square inches as your answer. So let's check and see if that's right using the formula. Let's check ourselves here. So, if we know that QR is 8, RS is 6, and now we learned that ST is 9, that means that of our whole trapezoid, we have a base 1 of 8 plus 6 plus 9. So really, base 1 is equal to, 14 plus 9, 23. And then base 2, this is also 9 up here, is 8 plus 9. So our base 2 is 17. And our height is 9. So if this information is true, we should be able to do 9 times 23 plus 17 divided by 2. So our area equals 9 times 40 divided by 2. Simplify. We're left with area equals 9 times 20, and that is 180. So we are good to go. Now, just for fun, I have one more problem. And this one seems complex because we have crossing dotted lines. We have a shape that's not in the same orientation that we normally see trapezoids. We typically see them like this. So this one might be a bit of a brain bender, but let's see what we can figure out. So I'm going to highlight things as we go again. Trapezoid ADEF, ADEF is made up of a parallelogram, ABEF, and a triangle BDE. The area of parallelogram ABEF is 84 square meters. Find the area of trapezoid CDEF. So we need to find C, D, E, and F. Ooh, okay. So I'm going to start, let's work backwards because it gives us a lot of information and there's a lot of other numbers on this picture. So if we're finding the area of CDEF, we need to know the height, we need to know its bases, and we have to divide that by 2. So I'm going to keep track of the information that we know over here to see what more things we need to find out. So if we're looking at this, the parallel sides of our trapezoid are going to be our bases. So that must mean that this is a base and this is a base. And it looks like they tell us that CD is 8 meters. So I know that's 8 meters. And we looked in our last problem, because we know that parallelograms, opposite sides are equal in length. So if AB is 5 meters, that must mean that FE is also 5 meters. So we have both of our bases, and now we need to know the height. And so the height is going to be perpendicular to those bases. So I'm going to grab a different color. And so if this here is going to be our height, we got to figure that out. And we don't know that yet. Luckily, though, we have other information that we can use to help us figure that out. So we're going to put purple on hold while we try to figure out the height. they tell us the area of a parallelogram. So I know area of a parallelogram is base times height. So in this situation, with that parallelogram ABEF, we know that the area is 84 square meters, and they tell us that the base is 5. So that must mean that we have we know this piece, we know this piece, and that variable, so we can use inverse operations to find that height. And it looks like the height of this parallelogram is also going to be the height of our trapezoid. So let's do some math. 84 equals, our base is 5, times h. Let's do some inverse operations. We're left with 84 divided by 5. This does not going to play very nicely. This seems like a terrible problem. Bro, whatever. I know that 80 divided by 5 is, 40 divided by 5 is 8. So this is going to have to be 16. And then we're left with 4 divided by 5, which is 4/5, or 8/10, or 0.8. So I'm going to call this 16.8 meters. So our height is 16.8 meters, which also means now that we know the height of that parallelogram. The height of our parallelogram is going to be 16.8 meters. So we have all three variables that we can now use to find out what is the area of that trapezoid. Now I am having a moment of doubt because it seems weird that we have a decimal, but it looks like the math is checking out. I mean, going back to that parallelogram, our base is 5. It told us the area is 84. So let's just go with it and see what happens. So purple area time of trapezoid. Height is 16.8. Our bases is 8 plus 5, and we need to divide that by 2. So area equals 16.8 times 13 divided by 2. I guess we'll simplify before we multiply. I'm going to divide that by 2, and you know what? I'm going to divide this 16.8 by 2, because I know that's going to be 8.4. Half of 16 is 8. Half of 8/10 is 4/10. So our area equals 8 4/10 times 13. Okay, well, I guess we might as well do some multiplication. Let's see. 8.4 times 13. Let's see. We move it one place, and let's do our multiplication. 3 times 4 is 12. 3 times 8 is 24. Plus 1 is 25. And then now we're just doing 10 times 84 is 840. Add them up. 2, 9, 10. And we need to move it back one place. So our area equals 109 2/10 square meters. Okay. I think that's about all I got. Seemed pretty good to me. So, as you can tell, lots of math, but if you slow it down, look at what you know from that problem, label it, and then it seemed like organizing the information by writing what we know to see what we don't allowed us to use algebra to do some calculations.